He is the author of 7 best-selling books, including the #1 New York Times bestseller, What Should I Do with My Life? His most recent book, entitled Decoding the World, right here, A Roadmap for the Questioner, is a dialogue on the science of our future with Arvind Gupta, founder of IndieBio and a general partner at the Mayfield Fund. He is also working with Arvind on the formation of the Genesis Consortium, a consortium of corporate partners and investment funds that focus on bioengineering at scale in order to address the health and planetary crisis that we are all facing. Welcome, Poe.
Thank you, Nancy. Thank you so much for having me. And thanks to everyone here for giving me a little time to share with you just a little bit about me before I go into a little presentation on the thinking behind Genesis Consortium. I'm originally from Seattle, but my family was from central New York originally. And I am a California person. I'm here to you today from San Francisco. I have the IndieBio lab behind me. We have COVID testing companies that we spun up using CRISPR assays here in the lab that's active behind us. They get us tested every single day. It's incredibly accurate. It's fun. I've worked in the healthcare sector in New York with Montefiore and through Epic Systems and with Raul Vasquez in the Bronx doing an ACO, and in Western New York with the So apologize for that. So quick little review of the last 50 years of sort of economic theory. In the 80s, we began to understand we were living in an information economy. And in the 90s, we realized we would all be, most of us would be knowledge workers, at least outside the healthcare space. And we began to move industry around the world, resources and manufacturing around the world. By the thousands, by the aughts, we began to really focus in high growth sectors on building a digital universe, a virtual version of a layer onto the world. And the problem, what happened with the 90s theory was that all of a sudden, all knowledge became online and free. And the concept that we could derive value out of knowledge alone started to disrupt and fall apart. Over the last decade, we've seen really significant growth in inequality, as we've seen suppression of wages, which we'll get to, related to healthcare costs. And recently, in this year, we really struggled with our industrial sector going, wait a minute, we can't make ventilators, we can't make masks, we can't make toilet paper. Our food sector was starting to fall apart. And with that in mind, we felt it was important to launch Genesis Consortium, which is something bigger than IndieBio and bigger than SOSV. And it is an alliance of like-minded investors who see the big picture and understand, most importantly, how hard it really is at the early stages for an early life sciences company. It is so easy to get distracted by the big dollar deals that happen at Series A and imagine that all these life science companies are doing so well. And to sort of tell a fable around this, I want to use, that has some important lessons. I want to tell you a bee story. Now, I'm using bees because the funny thing is about bees is that in a very divided society, bees don't divide people. Everybody loves bees. More people are concerned about the future of bees than are concerned about climate change. It's one thing you can surely talk about at your Thanksgiving dinner with your family, and everyone will be supportive and want to get involved. Bees are amazing creatures. From a sports physiology side, which I used to do, I'm particularly fascinated with the way that their muscles run inside their exoskeletons rather than on their skeletons, and the way that their muscle fibers work to beat those wings so fast and yet somehow still survive and not tire out. There are so many things to like about bees. Scientists have taught bees math. They use yellow for plus and blue for minus, and they show them grids of colors, and then they make them subtract and add, and they go down different pathways. So they're strangely smart. They do an incredible waggle dance that tells other bees where the pollen is, and dancing is their kind of language. Pollen is really flowers, essentially a flower's sperm. It's full of protein for the bees. My favorite thing about it is these saddlebags that they'll create. And bees, as everybody has heard, have had massive colony collapse problems over the course of this decade. And every young person is very aware of it. And everybody starts pointing fingers. And this element of pointing fingers, this thinking process, is what I want to address a bit for a moment. Because we don't really know what's causing specifically bee colony collapse. To this day, we don't actually know definitively what's causing it. People blame obvious targets, like the problem is pesticides, but we describe this way of thinking as a tendency to start swirling in and in a vortex start to blame everything that, in this case, bees touch. So it can come the homogeneity of bees, and then people start saying the real problem is monoculture, and then someone ups that and says the real problem is big food, and it inevitably quickly gets to, and this is all over the internet, the real problem is capitalism itself, or the lack of regulation of capitalism. And we describe this at IndieBio, this way of thinking about the future and solving problems, as the black hole effect. A black hole tends to suck in everything around it. And in our way, we see that the way people often start talking about world problems is they swirl in everything into it. Now, when we're on the ground, it's been here in San Francisco and now in New York, and we're trying to solve these problems, we don't have the luxury of fixing pesticides, of fixing big food, of fixing capitalism, of fixing regulation to sort of solve a problem. We have to get going and get moving and run experiments. And where we started here was at the simple interface between a bee and the flower. And an entrepreneur from Latin America sent us a science paper speculating and showing some science around natural plant compounds that help plants immune system, and that helps plants repair from cold weather and wear and tear. And we believed that these same compounds were shared with the bees, and that we didn't have to solve the bee problem. We didn't even have to know what was causing colony collapse in bees. We just needed to boost the bees' immune system so they could survive a plethora and variety of challenges. So with our model, the beauty of our model is the cost of funding this science and taking the risk on the company was very inexpensive. For just $250,000, we could see where this could go. And we created the company BeeFlow, and they created their jelly that went into the hives, which is a natural compound. And they were here in California, and they went out to the almond growers and the blueberry growers and the berry growers, and they said, don't you want your pollinators to use this? And they said no. And so they went to the pollinators, and all of the pollinators said, don't you want this natural thing? It's going to help the bees. It's going to protect your bees. It'll be better. And it turns out that pollinators just didn't want the risk. They didn't want the risk at all. And they've been doing pollination for 100 years just about the same way. And so our company realized they had to found some small farms, and they had to start getting to work themselves as a pollinator. So they thought they were just going to supply this juice. Then they start getting to work with bees in the field. And being scientists, they were like, well, let's be scientists about it. They put cameras on all the flowers. They put sensors on all over the farms, and they began to map the flight of bees, and they began to understand the flight patterns of bees and how flight patterns could be adjusted and improved. They also began to understand one of the real problems here, which is that when you let bees out of a hive, they don't actually know what to go pollinate. And they found a way to prime the bees to go immediately pollinate what they wanted. Even then, they had an enormously hard time. We were so excited about them. I remember seeing them and I was just thought, oh my gosh, they're saving the bees and they're growing bigger almonds and better yields and berries. My heart goes out to these guys for this incredible success that they're going to have. And in fact, it was extremely hard. And they all over Silicon Valley, they couldn't raise money because even though pollination is a 60 billion market, it's so fractured, so many tiny players that investors are worried you couldn't consolidate the market. And they worked for a whole year using that $250,000 and couldn't raise money until they ended up there on Park Avenue. Osprey, which is a hedge fund, and Driscoll's, which is the world's largest berry farmer, gave them a shot. Now, go back to how we were talking about the black hole effect thinking. The thinking was it was big food that was to blame, and it was capitalism itself that was to blame. But here, our little tiny company was pulled out of the dustbin by Wall Street and biggest berry farmer in the world as their partners, and began to do work that was extremely exciting, showing incredible increase in crop yields. And one of the most exciting things that they were doing was that normally in the world of berries, the winter season is a fallow season. They have berries that'll grow in the cold, but they don't have bees that can pollinate below 50 degrees. Bee-Flow's bees were turning that fallow season into a productive season. And now, finally, 3 years later, they are raising their Series A, and the company is doing enormously well. And so if I was to treat this as an algorithm, it was quite simple. Scientific insight plus Wall Street plus big industry. Very contrary to how many young people are thinking about our world and thinking about what we need to do. Now, I'm a big fan of Spotify. I think Spotify really understands young people's minds. They put out a report last week telling all the marketing and advertising people around the world that 60% of millennials and Gen Z want to rebuild society from the ground up. And it is this type of black hole effect thinking that we have to get rid of everything and start over. That is fundamentally a challenge to all of us. And it needs leadership to take us through that, to understand that we have the greatest economic opportunity in front of us of our entire lives. This is a map of the global economy in 2043. That's 23 years from now. The world's economy doubles every 23 to 24 years. The world's economy today is just under 100 trillion. And we have another 100 trillion in growth in front of us in just the next 23 years. But we have a challenge around that growth, which is the ability of the world to supply the resources for all of this. I won't go through all these stats, but this is if we add 2 billion to the population, we're looking at coal, meat, fish, aquaculture, plastics, cars and light vehicles, and sawn wood. And you begin to really worry that the world doesn't have the capacity to sustain this growth. This is very common thinking, that the growth challenges of the world are driven by the population boom, This is incorrect. The real issue, looking at our next 23 years, is actually the side effect of a very good thing. So much of the world, every year, 160 million people are joining the world's middle class. In many of these countries, they're on track to reach a Western standard of living. A Western standard of living uses far more global resources than being impoverished or even just being in the global middle class. We need 4 Earths. If we take what we're currently extracting from the Earth, we need 4 Earths worth of global resources just to handle the increase in demand from these 5 countries catching up to the Western standard of living by 2050. 4 Earths worth of resources. That's a lot. So how are we going to do that? And we look at these challenges in healthcare. We look at what on the top is the cost of hiring someone as an hourly worker. On the bottom, the gray line is what they're actually paid in real wages adjusted for inflation since 1970. You can see that real wages have not gone up, but the cost to a company has gone up. That's the cost of healthcare. And when we talk often about climate and the climate bomb that we're facing, I would actually say that the diabetes bomb is far scarier to me. We had 6 million people with diabetes in 1990. We have 29 million people today, but we have 84 million with prediabetes today, and a quarter of them will have diabetes within 5 years. Adding 21 million people to the diabetes population, and the cost to our healthcare system and the burden on wages is going to be an incredible challenge if we don't do more to solve it. I want now to offer you some hope to help with that. Understand that 97% of the human body is just 4 elements. Add in 7 more elements, you're up to 99%. All living things are 25 elements. And it has us wondering, what if there was an algorithm that could transform one thing into another thing, that could strip off this, add this, strip that away, add that, and everything that was waste could be turned into everything good. That exists. We've been using it. It's been called chemistry. We rip things apart in multiple steps. We use enormous amount of chemistry and an enormous amount of pollution and problems from it. The beauty of biology is that it is really an elegant form of chemistry. Just starting with bacteria. Bacteria, you should think of them as little transformation machines. There is, of the trillion species of bacteria on our planet, not to mention the ones we can engineer, just already there, they will transform one thing into another thing. And in fact, across the proteins and the enzymes of biology itself, we should begin to think of bacteria less as a microbe and not as a germ, but as essentially a transformation algorithm. And understand that we transform matter using biology. So here's just a few examples. Companies we recently created, 4 of them related to the construction industry. But here, by using enzymes brewed in bacteria, we can drastically reduce the cost of treating soil that's contaminated to allow us to develop new buildings and new sites. Concrete is the world's 2nd most used material after water. China has used more concrete in the last 4 years than the US used in the previous 100 years. We can actually store CO2 in the concrete in the form of aggregates and stone, and we can 7x the opportunity in the concrete sector. This is our company Carbix. All of that PVC that comes from all of the windows and frames from construction sites, it's been unrecyclable until now. until a discovery out of the IndieBio New York program just in the last few months, an enzyme that can take all this unrecyclable PVC and make it recyclable and reusable. And here in San Francisco, this reactor uses sound at high frequencies to blast apart all waste, even mixed waste, and turn it into renewable fuels and chemistry. Those 4 companies I just mentioned, we did those just in the last 5 months. Just in the last 5 months, with 16 other companies too. These are solvable problems. They're more than solvable problems. They're incredible opportunities to invest in that can transform the world. We were surprisingly named the most active investor in the US in Q2. When the economy had fell by 34%, we didn't stop. We thought that was a blip. Turned out we were named again in Q3, the most active investor. Here's a simple problem we have not solved. They've made movies about forever chemicals. Forever chemicals, I love them. They're on my nonstick pans. I have a lot of nonstick pans in my house. It's incredibly hard bond. The world, Bill Gates just put a ton of money to fund a company to try to find a bacteria or an enzyme made by a bacteria that would break these bonds. If we can break these bonds, then we can use these bonds. And these things go from being now seen as an evil into an incredible renewable resource. The tree of life is programmable just the same way that computers are. We have to learn that code, but we can train the tree of life to create literally everything that all over again. From CO2 off cement factories and fossil fuel plants, we can make fish feed. From that same type of CO2 or using sugar, we can make indigo that's currently so toxic, it's only done in Mongolia and it's banned around the rest of the world. All of our beloved blue jeans can actually be sustainable. It's not just CRISPR. This isn't just the era of CRISPR. We have so many ways to alter the expression of genes, and we are swapping small RNAs at all times. So down there in the lower right, milk and vegetables alter gene expression. Yeah. Every time you kiss, you swap small RNAs. Programming fungi, we can make bacon and tuna. We can make materials. These are some of the companies people have talked about in the earlier era. We can coat satellites to protect them from gamma waves. With algae, and here we go with AlgaeKnit. This is New Wave Foods, a New York company, Beyond Meat of shrimp. Here's AlgaeKnit in Brooklyn, Aaron's company. Here's what Steve was talking about, that we all know how stem cells can help us with diseases such as Parkinson's, but we also use stem cells to replace the slaughter of animals and to make meat. This is the larger vision that we have for Genesis Consortium, which is to unite people in the long-term vision so that we can provide the resources to these young companies and these scientists to help human and planetary health, which to us are really just both health. The world is an ecosystem. Our bodies are an ecosystem. It's the same mechanisms. We share immune systems. And so that's the vision behind Genesis Consortium that we're creating. It is a vehicle, a small, very, very small financial vehicle, but more than that, it's an umbrella to shine a positive light on great solutions that are being brought to the world.
That's an amazing story. Thank you so much for that. You know, when I first started working with engineering biology in 2013, I was actually hired by the Sloan Foundation to take a look at what was then an emerging field of synthetic biology, which really had been started by a few scientists from Harvard and MIT in the early 2000s. And then they had created a consortium of academic institutions called SynBirk, which included not only Harvard and MIT, but Stanford and UC SF and a few others. And their goal was to build an industry around this new science. And no one really understood what it was. No one knew what it could do. It was very hard to talk to anybody about it because nobody could understand that you could actually, manipulate genetic code on a computer and then produce the results from it. But slowly, organizations started getting out there. And I know even your organization, IndieBio, had a hard time convincing the investment community initially that you were just playing in a sandbox, right? And that
It's still hard, Nancy. It's still hard. It's so hard. Like everybody should understand that most of these companies are starving and most of them die, no matter how amazing what they do is. And we see the huge Series A's and we think that's happening to all of them. It's happening very rarely.
Yeah.
And really so much great, incredible early support. New York has such a great ecosystem. It's that jump between super early and that Series A, that gap where it is the danger is saying there's a lot of money. We don't need a lot of money. What we need is organized money. Finding investors who will write first checks. That's what our goal is to do in the ecosystem. We're happy to write first checks. We're comfortable with this risk. Actually, a lot of the universities and other programs are also writing first checks. It's finding lead seed investors, series seed leads, and getting a lot of series who are willing to diligence companies and represent to other investors. We're taking the board seat. That's the hardest part, that organized part.
Yeah. Well, venture capitalists have a system of their own, and most of them don't like to travel to visit their companies, number one.
Yeah.
And so it's kind of a closed culture there. How do you get that message out, and how do you get these venture capitalists to be able to take the risk on companies which may not be in their backyard?
Well, they are going to be in New York's backyard now. They're in New York's backyard now. And I think there's an incredible opportunity. Yeah, it's an important point you said. They don't like to travel for their companies. And they want to be able to keep a watch on them. They want to be able to come by. And in order to handle a certain number of boards and a certain number of investments, they want to be nearby. It just makes it a lot easier. That means that the companies in New York have an opportunity with New York investors, where other investors from other cities might, like I literally was hearing this last night from investors. Like I want a Silicon Valley investor. I want to do this company in Boston, but I don't want to have to fly to Boston all the time. Like I'm going to try to talk them to move here. I think New York has an incredible opportunity here.
So you just got through your pitch days.
Yeah.
Explain that a little bit and tell us what you saw that you were most excited about. I mean, you shared some of that.
Yeah. We on Tuesday had our IndieBio New York it's demo day, and Wednesday, just yesterday, we had our San Francisco demo day. What we found is that during this unfortunate working from home lifestyle is we've been able to 3x our audiences. Now, every university accelerator, every other programmatic accelerator is also doing demo days. IndieBio has always had very large audiences, but we were able to have on investor level some 800 to 900 investors attend both days. And we hope that translates into moving the companies along. The challenge from here is that investors have to gain faith in these companies without having met them in person. And that is actually very hard. And so the common practice is to, if you like something, take a walk at a social distance. And if you're in a different city, find a friend of yours in that city who will take a walk with those founders for you. But it becomes harder.
Yeah.
More meetings than ever are required to make a deal happen now.
Yeah.
But Poe, aren't a lot of the investors, at least their fears, somewhat quelled by the fact that you and your team have already done the due diligence, right? So earlier we were told you would have, that's probably an 8-to-1 culling ratio of firms that come to you and that you determine are worthy of being taken into the incubator process. One would think that the investors would take that with some solace and say, you know, they've done the due diligence that we wouldn't otherwise not have been able to do.
Absolutely, the signal that comes off being at IndieBio and having someone like Steve Chambers, who's amazing with his history, be able to inform investors, that doesn't preclude an investor from their fiduciary duty and their duty of care to fully have done. So there's strong signal, right? But what it means is it's easier than ever to join a party round and harder to get lead investors to drive rounds. And it's just the specifics of round dynamics that are at work here. As soon as a deal goes off, everybody wants in. It's the sort of who wants to do the extra work and make the commitment to take that board seat and to have done all this diligence on others' behalf. That is a little trickier. And there's so much money, there's also so many startups. We're seeing a lot of investors struggling with, there's so many good ones, how do I choose? Yeah. So things are going extremely well for us, but I want to assure it's not easy. Yeah.
How will the Genesis Consortium actually work then? Wow.
Yeah, so Genesis Consortium is going to sound like a very small thing. As the investment vehicle, we're just raising 10 million for that. And what that does is it pairs up with our 250,000, and it's less about the money than it is about the network. Again, it's about having this network, growing up a startup with professional investors. The startups tend to come out if they have university money or if they have friends and family money. These companies are looked at just very differently by professional investors, and professional investors needing a network of professional investors around them. So the idea is to give a little more money to the startups, a little more time to hit milestones, and then have a network of professional investors that can help advance them.
Okay, great.
Yeah.
Well, listen, that was a terrific presentation. I love the story about the bees.
Thank you.
Wonderful way to close, showing how such a serious problem could be solved. You know, and just perseverance is required, and just a little bit of ingenuity and imagination.
Yeah.
So thank you very much for closing our
Thank you.
symposium, Bo.